the saw in your villages, that, or if you go to internet you can see saw. So the tooth of the saw looks like this. That's why it is called sawtooth pulse, because each cycle is one pulse, so that it's pulse continuously coming. That's why it is called pulse train. Pulse train. So that today we are going to find out the Fourier series of sawtooth pulse train signal. So for that, we need to know the x-axis and y-axis. You can see the since x-axis is time based and y-axis is f of x of t. So we need to know what is the function of this signal and what is the limit of this signal. Okay. So limit, as you know, this will be one cycle period. So here is the 0 to t is the one cycle. 0 to t is the one cycle. So t equals to, so the 0 to 2 is the limit of this function of signal. And the slope, we need to find out, because if we want to find out the function, then we have to apply the straight line equation. That straight line equation is amx plus c. C is constant in this example. So y equals to mx. So m is the slope and x is the variable of x-axis. So the x of t, because y-axis has x of t, so x of t equals to mt. So m is the slope. We need to find out the slope, because otherwise we cannot see what is the changes, because every time signal is changes, so that we can find the function is related to its rate of change of the signal. That is like the velocity. So we can find out the velocity, right? Because if we think the destination, final destination, the distance and the required time divided by the required time, we find out the velocity. Here is the same, because the maximum point is 2, and to reach the maximum point it takes 2 seconds. All right, so we can find out the slope or rate of change of the signal. So here we have find the same way, 2 by 2. So 2 to cancel out, so it becomes simply t. It's easy function, right? Another one is omega equals to twice pi f. However, f equals to 1 over t. So that 1 over t is coming here with the 2 pi. Value of omega is pi, because 2 to cancel out, so pi radian per second, angular velocity of the signal. Now we can find out the A0. A0 is the DC component of the signal. So we have to apply that basic formula, 1 over t, 0 to t, x of t dt. And 0 to t equals to how much? T equals to 2. So we can put 2, 1 over 2, 0 to 2, t dt. So if we do integration, then we found square by 2, limit 0 to 2, then if we put the value, then we found the equals to 1. All right. Now the question, then what is the sawtooth DC value of sawtooth pulse train? It is 1. Such as if we give the maximum value of the signal is 5 volt, then the DC value will be simply 2.5. You can calculate yourself. It will be 2.5. Okay.
Yes, sir.
itself, if you change the value here, maximum value, you can see this one. But if you change in simultaneously the time and value, then the result will be different. But within in the same constant changes, if you change the maximum value, you will get the half of maximum value equals to DC value. That means here is the DC value of this signal. Okay. So in case of multiple choices, sometime you can get some questions of what is the DC value for the given pulse width signal, given sawtooth signal, sawtooth not pulse width, sawtooth signal. Then you have to instantly remember, yes, the DC value of sawtooth wave signal is half of the maximum magnitude. All right. So you can write down easily. It's a shortcut thing. So whenever you solve some problem, you have to find out what is the significance of doing this job. Understand?
Yes,
That
sir.
means you have to find out the intellectual things from the equation, because every equation has a meaning. So our target to find out the meaning. Otherwise, we don't do this example. So here, so we have found the A0. Now AN. N formula is also 2 by pi 0 to t x of t cos n omega t dt. And it's equals to t, we can put the value of t equals 2. So 2 by 2, 0 to 2 t cos n omega t dt. Then 2 to cancel out. So we have simply 0 to 2 t cos n omega t dt. So here the two function has been found. One is t, another one is cos n omega t. So we need to apply the integration by parts. So that means u v formula, u and v. The main target of to consider u and v, you can change v, u, your t can be considered u or v. But the interesting point is, if you don't consider in that way that you will get some result, then it will be useless to consider V as T and U as a cos n omega t. Because if you consider cos n omega t is U, then your problem will goes continuously. There will be an end. In the middle, you have to consider, okay, this must this. So you have to replace in that way. But if you consider that U as T, then you can find solution easily. That's why in the problem we have considered T as a U. And another thing is that if you see the formula here, du by dx, right? Du by dx. So if you consider some variable in that way that this differentiation will cancel, then it's easy to integrate, isn't it? So that u has been, because the variable is t and another t considered as u, so dt can be cancelled out, so that we can do integration easily. That's why t considered as u and cos n omega t considered as v. Up to this, everybody understand?
Yes, sir.
Yes, sir.
Okay. All right. Thank you.
Yes, sir.
All right. So first integration we have done cos n omega t. Cos n omega t is sin n omega t. T was outside of the integration. However, in the second line, after that line, t is inside the limit, because t is the variable in the problem. So we cannot keep, and t value limit is 0 to 2. So whenever we have the limit, we cannot keep the variable outside of the limit. because limit is there is for that variable. So if we keep the variable is outside of the limit, then it is not any more variable belongs to that limit. However, in our problem, the t is the variable. That's why t keeps inside the limit to 0 to 2. That's why t multiply with the sine n omega t. And second integration, we can find out the cos n omega t. Then if we do integration, then we can find out the sine n omega t divided by a n omega. So n omega take it out from the limit. Here is another interesting point. We can put the omega value is what? Pi radian per second. Remember this one, if we go back here, omega equals to pi radian per second. So if we put the pi, then automatically sine becomes 0. So that first term of the equation is 0. All right. Now second term minus 1 over n omega t, n omega, sorry, n omega, 1 over n omega. Another integration coming, so it will be another 1 over n omega. This will be multiplied. That's why it is written 1 over n omega whole square. And sine n omega t becomes minus cos n omega t. And limit is 0 to t, 0 to 2. So the minus 1 over n omega whole square, and whenever put the limit, then it becomes cos 2n omega. Let's see why it is here like this. 2, if we put 2, then 2n omega, okay, and minus sign. Minus itself, another minus coming because of putting limit here, the lower limit. So minus into minus cos 0. So cos 0 is 1, and minus, and this minus becomes plus, so that 1. So 1 minus cos n omega, twice n omega. So if we do this, then what is coming here? Cos n twice pi. Okay, so twice pi. Pi, how pi coming? Because of omega's value is pi. Cos n omega, n value 1, 2, 3, 4, whatever you put, is cos twice pi. That means it's always 360. 360 multiplied with something. And cos 360 value is always 1. So 1 minus 1, 1 minus, it becomes 0. And that's why an becomes 0. Okay. Now our third coefficient, bn, we need to find. Bn we need to find. Bn equals to 2 over t, 0 to t, x of t, sine n omega t dt. And again we put the t value. So 2 over 2, 0 to 2, t sine n omega t dt. So simply we have got 0 to 2 t sine n omega t dt. Here also we need to apply integration by parts formula, because here is u and this one is b, ub formula. So similarly we do the integration of sine n omega t. This line becomes here. Okay. So sine converted to cos, and minus sign is coming here, minus 1. The interesting another point is the cos 0 will be 1. So there is no problem. And cos 2 n pi, again coming pi. So 2 pi. So here is no problem, I think. So far we got. Look, this value t. T value whenever you put, what is coming here? 0. Okay. Whenever put 2, then 2 into cos 2 pi n. So if you put n value whatever, so it does not matter, so that it's easy to get this value, this line. By n pi cos n twice pi. So second terms of the integration, it is 1 over n omega whole square, because I have double integration from this integration, this one, and another integration from there, this must come. So since here sine n omega t comes, so obviously it is gonna be 0, because omega value is pi. Sine pi value is 0, so always this second term is 0. That's why it's 0 here. So the Bn value coming minus 2 over n pi cos n twice pi. Okay. So whatever the n value you keeping, this total term becomes 1 into minus 2 divided by n omega. N pi, sorry, n omega means n pi. So it becomes minus 2 divided by n pi. So we have found the Bn value is minus 2 divided by n pi. So our Fourier series is A0. We have got 1, and summation of an is 0. So we don't need to consider n. So Bn coming, coefficient is minus 2 over n pi. So minus coming in front. You can consider the first fundamental frequencies available. Then the second harmonics also available, third harmonics also available. But all are sine terms. DC value and sine terms are available. No cos term available. All right. So do you have any question, or do you understand? Everyone understand?
Yes, sir.
Okay.
Yes, sir. Understood.
Any more question regarding this? If you have question, you can ask me. Otherwise, we'll go to next example. Next one will be more interesting, because the next example is familiar to you.
Sir,
Yes.
in the t integration 0 t sine n omega t dt. Sir, why we include t?
Okay. T integration, the Bn.
Yes, sir. Yes, sir. Why we include t between,
Oh,
sir,
that I
the
asked,
limit, sir?
I explained, but I am repeating. The t is the variable of the equation. Limit for whom? Limit 0 to 2. Limit for whom? Limit for t. Because if you see the figure, x-axis is the t, time.
Yes, sir.
So if you consider 0 to t, so whose value? T's value, instantaneous value, and it becomes a solid line up to 2. So it's t's value. So whenever is limit available, then you have to think that variable is inside the limit. If I give you another example, that you are living in where, such as Shakib living in Uttara. Okay, Shakib living in Uttara. You need to write down the address in online. So there is a written CT. Okay, you have to write down the address, but there is written CT. Then what you will write down? Dhaka, right? If
Yes,
you
sir.
write down the Dhaka, then your address cover, that's Uttara, belongs to Dhaka, right?
Yes, sir.
So here also similar thing, 0 to t, 0 to 2, whose value? T is value. So automatically the variable comes inside the limit. Such as if I give you one, the 0.1, 0.1 belongs to 0 to 2, right? Limit.
Yes, sir.
So whose value? T is value. That's why T coming inside the limit. Okay?
Yes, sir.
T multiply cos n omega t, because we are doing respect to time. So T goes inside the limit. Clear?
Yes, sir.
All right. So our next example is about the finding of Fourier series for of half-wave rectified signal and draw its frequency spectrum. So everybody familiar with the half-wave rectified signal, right? Because you have learned the rectifier circuit, half-wave, full-wave, that is the B circuit. So you have seen the.
Yes, sir. In electronics, we see.
Yes, yes, thank you for recognizing the course. Thank you. So here you can see this half cycle, the negative half part is missed here. Negative half part is missed. So when we do Fourier series, we always consider one complete cycle. So in this case, one complete cycle is positive half cycle and negative cycle is completely one cycle. That is up to twice pi. So what is the limit of this? Then limit is 0 to 2 pi. One findings done. Another one is, what is the function of the given signal? The function of given signal is Bm sine theta, because it is the, you can see this is looks like a sine wave, right? So their function is Bm sine theta. So we have got another one is, what is the omega? Omega equals to 0 to twice pi f. F is 1 over t, and twice pi by twice pi equals to 1, because twice pi cancel out. So omega value is 10 per second. All right. So that A equals to 1 over twice pi, 0 to twice pi theta. Then we have to put the x of theta equals to how much? X of theta is Bm sine theta.
Bm sin theta.
Limit, we have to break the limit, because 0 to pi signal is existed, signal exists, and pi to 2 pi there is no signal. That's why we have break the limit, because limit will be 0 to pi plus pi to twice pi. Okay, so that we can find out here Bm sine theta d theta, and next part gonna be 0, this part after the 0. So we have simple integration. Then Bm take out Bm by twice pi, and sine theta is minus cos theta. And if you put the limit of this, then we have found that A0 is Bm by pi. A0 is Bm by pi. So if I give you, here is the trick. If I Bm is 220 volt, 220 volt, then what will be their DC value?
Sir,
220
So 60,
divided by
64.4.
pi. Yes, thank you. Thank you, understanding. Okay, 220 by pi. This also a kind of MCQ, that half wave rectified signal, DC average value how much? Bm by pi. If Bm is this value, then what will be the DC value? Then you can find easily. I think now you can remember you rectified signal, because in that case they have derived, but at that moment, how they derive, you don't understand, right? Because in their derivation, they did not explain this function, this omega value, and the limit. They just give the direct equation 1 over twice pi 0 to pi Bm sin theta d theta. That the DC value is Bm by pi, right?
Yes, sir.
But in Fourier series, now you are clear why DC average value of half wave rectified signal is Bm by pi. Full calculation. Find out the AN. AN value we can find out by applying the same formula as we have done earlier. The 1 over pi 0 to pi here is, or in original equation there was 1 over pi 2 twice pi, right? X of theta cos n theta d theta. But in our case, we have broken the limit 0 to pi because the signal exists or not exist. There are two states. So we broken this one in terms of it is actually 0 to 2 pi, but we have broken 1 over pi 0 to pi Bm sin theta cos n theta d theta plus 1 over pi pi to twice pi. Here the another one, pi to twice pi, then 0 twice pi limit, then 0 d theta cos n theta d theta. So this term is 0. That's why we have made little bit short, one line shorter. Okay, anyway, so we can go forward. There is no mistake here. So Bm by pi, Bm taking out from the limit, then we have sine theta cos n theta d theta. So sine A, sine B, cos B. Okay, sine A cos B. So for that, we have to multiply 2 with this. So we have done in the next line, the 2 sine theta cos n theta d theta. We have considered these two and these two going to be cancel out. So original equation keep itself. Then Bm by twice pi 0 to pi, then sine n plus 1 theta minus sine n minus, because if you want to find out the 2 sine A cos B, then the equation is sine A plus B minus sine A minus B. Okay, that has been applied. We can now again Vm by twice pi 0 to pi sine n plus 1 theta d theta minus 0 to pi sine n minus 1 theta d theta. So simply we do the integration here. Integration. So sine theta, as you know, minus cos theta. So simply here, so minus cos n plus 1 theta divided by n plus 1 0 to pi. Again, here is sine n minus 1 theta d theta. So minus cos n minus 1 theta divided by n minus 1. It is also the limit 0 to pi. After that, it's very that minus cos n plus 1 pi divided by n plus 1 plus 1 over n plus 1, because the limit, if we put limit here 0, so cos is 1. So this minus and the limit, putting limit, another minus coming. So this minus and that minus cancel, it becomes positive sign here. If you do yourself, it will be very good, and then you will understand very clearly, and you will not forget, or you will not have any confusion. So I suggest you to do by yourself. Then minus this minus coming here, and minus cos n minus 1 theta divided by n minus 1. So here you can see the theta value has been put pi, another one is 0. So it's going minus 1 over n minus 1. Okay. So here cos n plus 1, that means you have to apply cos A plus B formula. Cos A plus B and cos A minus B. This formula you have to apply. Then you will get the next line, cos n plus n pi. Let me show you the clarification of this line, although I suggest you to do by yourself, but here in the class I'm giving you the explanation how this coming. Cos A plus B, it is cos A sine A minus cos B, is it? No, cos A, cos B. This is cos B. Remember. So don't confuse with the equation, formula. Minus sine A sine B. This is the equation, the formula of this one. So here, if you consider this multiply n pi minus pi, coming sine terms is 0. Without thinking, we can write down 0. So what keeps itself? Cos A. Cos A means cos n pi. Pi. So cos pi value is minus 1. So this minus 1 will automatically come and cancel out itself. So it is coming cos n pi. So everybody understand this line?
Yes, sir.
Okay, here's the tricks. So I suggest all of you do this example by yourself. Although it is very long, but you have to have patience and confidence that you can do. Because in case of Fourier series, it is always long solution. It is not, there is no shortcut. Of course, there is shortcut that will come later, because we have another technique based on the signals. But until we go that technique, you have to solve step by step by yourself. So I have shown you one term. Another is similar way also. The cos n minus b formula is cos a cos b plus sin a sin b. That sign comes again 0 because of pi. So it is keep itself cos n pi. You can do itself. So it's becomes 0 when n equals to odd numbers. If you put n is 1, then cos pi. Cos pi means -1. -1 and this minus becomes plus. So 1 over n minus 1. So this is plus and this is minus. So it becomes 0. And this one also going to be the same because there is no minus sign. So here is a plus. So it's going to be minus. So minus and plus going to cancel out. So that it is written when n is odd number, then a0 an is 0. When n is even number, then we got minus 2 bm divided by pi n square minus 1. Okay, an is like this. So you can do the bn similar way. So ultimately you'll get the bn is 0. So I give you the task at your home to do by yourself bn. And also B1, why do you consider B1? Because B1, if we don't consider B1, then another error will be arised. Error we have given B1 separately because in our equation here was the sine n omega t, right? Or sine n theta, right? Sine n theta. N is 1. So sine theta. So sine theta means sine square theta. This formula does not follow the previous formula. That's why we need to do B1 separately. Okay, here's the tricks that why do we need to do sir B1 separately? Because we can find out from the AN. Bn. An is simple or the other way, Bn. However, Bn is 0, right? Bn, total Bn is 0, but B1 is not 0. Interesting point here. B1 is not in 0. If it is 0, then I'm very short. But unfortunately, B1 is not 0. That's why the Fourier series becomes Bm by pi plus Bm by 2 sine t minus 2 Bm by pi summation of 246. Why 246? Because the odd numbers are 0. That's why only even numbers. Or cos nt divided by n square minus t. This is the Fourier series for half wave rectified signal. And based on this series, we have drawn this frequency spectrum. Okay, everybody understand Majharo? Understand?
Yes, sir.
Okay, Iman Das, are you there? Okay, no problem. Understand, sometime network problem or sometime other problem arise. Now, as I mentioned a few minutes back, there are some shortcut techniques, and that technique based on the signal pattern. So now we'll discuss that signal pattern. And that signal pattern is shown here in this slide. But before going to discuss about the slide, I can tell you the title of this slide is Event Function Symmetry. If you see event function symmetry, definitely there is another odd function symmetry also available. It's like the day-night. If there is a day, definitely there is a night. Or if there is a night, definitely there is a day. So that whenever you see that even function symmetry, definitely there is a odd function symmetry available. To understand this even function symmetry, we need to go through the definition of this symmetry and objective of this symmetry. If we don't follow this function, the signal function symmetry, we can do the Fourier series as usual, as we have seen A0, AN, BN. We can do that more method, no problem. But if we use the symmetry function, that means the signal solutions, the solution becomes shorter, because here is some clue given. If we find the signal is even function symmetry, then coefficient Bn is 0. That means you don't need to calculate Bn at all. Only calculate A0 and An. These two coefficients will be calculated. However, we need to know what is the condition to be an even function symmetry. Here, you can see f of minus t, f of minus t equals to f of t. If any signal follow this condition, then the signal is even function symmetry. And if the signal is even function symmetry, then we will find only A0 and An. So our time is saved, energy is saved, and we can smartly find the right. So here we will see how can we find the function is symmetry or even function symmetry or odd function symmetry. Let me show you one example firstly. This signal, okay, this one, the triangle wave shape. Triangle wave shape, here I can show you this condition based on the time. If it is angle based, then it should be f of minus theta equals to f of theta. F of theta. Okay. So the later one is based on angle. The above one is based on time. So any kind of x-axis given, so you can find out the solution. So here, look at this signal. F of important message is symmetry. Symmetry means equal. Whatever you take time or angle from the origin, you have to take the same distance from left side and right side. If you consider, okay, sir, here is t by 2, I will cut it. Here is t by 4. Okay, very good. Here you have to do again. Here is t minus t by 4. Then you consider they are the same or same, definitely same here, but here is sign matter, plus or minus. Since there is no negative signal in the given signal, so definitely this will be the positive amplitude always. Okay, that's why f of minus t by 4 to whatever you consider, this might be half of a. If it is the a, what would be? Definitely it would be what? Half, right? T by 4, half. So A by 2, consider A by 2. It is an example. It is not, there is no concrete solution, this one, and this prediction. It's A by 2. Similarly, f of t by 4 is going to be A by 2, same, because there is no negative part of the given signal. There is no negative part. So both are same, right? So we can write down f of minus t by 4. Okay, so if this condition fulfilled, so the given signal is even function symmetry.
Yes, sir.
Everybody understand?
Yes.
All right. So if I give you the task, now can you solve this problem? The second, this signal is even or odd? In maximum value is A. The given signal is even or odd? I think you can find it, right? You know the technique. I have given one example, so you can find yourself. Another is odd function symmetry. Odd function symmetry definition is the function f of t is said to be an odd function if f of minus t equals to minus f of t. The difference between the two function is only the sign in front of the function. In even function, it was equal directly, but in case of odd function, minus sign coming in front of the f of t. That means positive value and negative value will be same, but there will be the minus sign. That means sign, the positive and negative value will be there. But amplitude same, but the value is only difference is minus sign. See that this is another example. Okay, I am giving you. The given signal is very popular signal. This one is sine wave. Bm, maximum value is Bm. So there is the, if we cut the middle of a half cycle, so it becomes t by 4. Similarly, in negative side, minus t by 4. Minus t by 4. So if we want to prove what is the function type, minus t by 4 equals to what? This is up to this. What is this? Minus Bm, right? Minus Bm, because the maximum amplitude of negative part is minus Bm. So it becomes minus Bm. For f of t by 4 equals to
BM.
Bm. So that what we can write, this is going to be minus f of t by 4. Yes, t by 4. All right. So here minus sign coming. So the condition is fulfilled for odd function symmetry. So the given sine wave signal, sine wave, any kind of sine wave signal is odd function symmetry. So if, yes, what is the question? Yes. You need to calculate for one cycle. It does not matter positive or negative. Because if signal is start from minus t by 2 and goes up to t by 2, that means this is a one complete cycle. If it is one complete cycle, start the limit minus t to t by 2. This is a one cycle period. So you have to break minus t by 2 to 0 and 0 to t by 2. Okay. Even it starts from negative side, negative half cycle, so it doesn't matter. It is continuous up to a one cycle. You have to always calculate for one complete cycle. That is the condition. You will see some steps. You will see some steps what you need to do. You can read those steps, then it will be easy for you to solve any kind of signal by Fourier series. Okay. Any more confusion or question?
No,
Because you have to be clear in the class. Otherwise, you'll be very confused in the home, because home you will not get any support. So if somebody does not get any support, then always feel very heavy heart. Very thought is what can I do? Becomes a puzzle man. Try to solve the problem in the class. And I can give you the extra time also in the after the class, or in your convenient. Let me know your convenient time. I can give you, no problem. But you have to understand, because you need to answer the question in the exam. No one will answer for you. So I was in the discussing that the where sine wave. Sine wave, you can see this, any kind of sine wave is odd function symmetry. If
odd function symmetry.
yes, if any signal is odd function symmetry, then A0 coefficient and AN coefficient are 0 automatically. You don't need to calculate. So you need to calculate only Bn. What is the Bn?
Yes, sir.
Okay. So here is huge time save. So it is smart work, right? It is a smart work. So you need to find out only Bn. And you know the Bn equation, right? Everybody knows Bn equals to, for this sine wave,
2 by t
t
integration of
0 to t and x of t, f of t, since here is f of t
f of t
sine n omega t
omega t
dt.
dt.
This is the equation,
Yes,
right?
sir. Yes, sir. We know it.
But for this, we are going to cut it half t by 2. Okay, half period. We are not going to average it, because if we do average, then it's totally going to mess up the calculation. So our limit going to be, because here is positive, here is negative, so sum of this will be 0, so that we will cut down in half cycle and find out. Okay. So any confusion?
No,
Or
sir.
any more question to understand the odd function symmetry or even function symmetry?
No, sir. We can understand.
All right. Okay, thank you. So we are moving to, here is the steps of solving a signal by Fourier series. So you read it and remember those steps, then it can help you. Here it is written, take a complete cycle for finding the terms of A0, AN and Bn. Complete cycle necessary. So here is the example of applying even function symmetry. Even function symmetry. All right.
Yes, sir.
That is the example of even function symmetry. If you see this one, wave shape, right?
Yes,
This is
sir.
the triangle wave shape. Everybody knows it. So this is the given signal which has the time-based signal and amplitude, maximum amplitude is A. Maximum amplitude is A, right? This is interesting. Although in rarely you can use this kind of signal, but you need to know what are the harmonics includes in triangular wave shape. If you want to find out the harmonics or DC value, apply Fourier series. Okay. So to
Yes, sir.
solve this problem, we need to find out firstly the given signal is even function or odd function. To prove that, we need to draw the negative mirror of the signal, right? Mirror of the signal, negative side signal. So here is minus t, here is minus 2t,
2T.
and it goes up to the minus t, smaller t. Amplitude same. As I mentioned, whenever see that there is no negative part of the signal, definitely you can predict even function symmetry. Let me go a little bit back. Very interesting point. As I mentioned that whenever you see there is no negative part, the signal is even function symmetry. Let me
Yes, sir.
go to the, we have solved the one problem, that is the Sawtooth wave. Let me see, Sawtooth wave is what kind of behavior it is. This one, okay?
Yes, sir.
This one, look at this. What is their solution? A0, even very fine. Then the AN total is 0. You see? Whereas even function symmetry, A0 and AN existed. Understand? So that, and here BN is existed. So my comment is not always correct, but you can predict, yes, the given signal can be even function signal if there is no negative part. But all types of signals are not even function signal, even function symmetry signal. Why? Look at, if I give you, this look like this. So if you take the symmetry point here and here, value are not same, only sign same, value are not same. So the Sawtooth wave is, we cannot apply even function symmetry for Sawtooth wave. It should be the equal side. All right.
Yes, sir.
So this is a triangular wave shape. So this is a even function symmetry because we can cut down this point.
Yes, sir.
And
Amplitude are
minus
same
t.
and
So minus t, f of minus t by 2 is A, f of t by 2 also A. So both are
yes.
same. So they are even functions symmetry signal. Symmetry signal. Even function symmetry signal. Okay. So Bn is 0. You need to calculate An and A0. Limit will be how much? Our limit will be t by 2.
0 to, yes, sir. T by 2. Sir.
Because here is positive slope, here is negative slope. Whereas
Negative slope.
there, if we do the average, it will become 0. So slice it in half cycle. Here is the one cycle complete. Understand? Here is the one cycle complete. That means here is pi. pi is the half cycle, half period, right? Pi is the half period. One cycle period. Very interesting. Because why I am telling you interesting, because there is a difficulties. If there is difficult, that is interesting. So that y equals to mx, we need to apply this straight line equation, because the signal is RAM type. If RAM type, that is the rate of change. Okay, so we need to find out the function by applying this straight line equation. The next is here we have found m equals to a by t by 2.
T by 2.
A t by 2 coming, because the maximum distance and maximum amplitude is a, and to reach the a point, it becomes t by 2.
T by 2.
Yes, any question, please?
No, sir.
Okay.
You can continue.
All right. So a divided by t by 2 equals to 2a by t. So we have got slope. So x of t equals to amx equals to t, and am equals to 2a by t. So it becomes 2a by t into small t. And omega becomes 2 pi, and t equals to what? Pi, as I mentioned earlier. Here, signal. Here is pi. The period time is pi. So t equals to pi. So cancel. So it becomes 2 radian per second. Now we can find out the A0 and AN. We don't need to find out BN. So A0 equation here was changed because there was a t 1 over t, right? Here we consider limit is t by 2. So 1 over t means 2 by t. Everybody clear? So 0 to t by 2, 2a by t, t dt. After doing this integration, then we have found the a by 2. A by 2 is the what? DC value. A by 2 is the DC value of triangular wave shape signal. Very interesting point here. Look at this point.
Yes, sir. This is the half of the maximum amplitude.
Yes, thank you. You recognize, thank you. And you can consider also that the sawtooth wave also had the half, right?
Yes, sir. DC value is maximum value.
Yeah. But I suggest, because in case of sawtooth, their time difference can be changed, but in triangular wave shape, they are equidistant, so that they will be always half. There is no doubt. All right. I suggest you to solve that sawtooth wave by another variable, another time variable, like t equals to 3. You can solve at your home, okay?
Yes, sir.
And let me know. So we have got half A0 value. Now is AN. AN is 4 divided by t. How does it come? Because AN equation was 2 by t. Right? 2 by t. However, t equals to t by 2. So 2 divided by t by 2 becomes 4 by
T.
t. Clear?
Yes, sir.
All right. Very good. Thank you. Now 0 to t by 2, 2a divided by t. This coming from the x of t function, and cos n omega t dt. After that, 2a taking out from the limit. So you got 8a, and this t also taking out, so t squared. So 8a divided by t squared. And now very simple, t cos n omega t. you can apply like the previous problem, UB formula. Okay.
To be formula, sir. Yes, sir.
Yes, UB formula you can apply. Then eventually you will be reached to at the point 2a divided by n square pi square cos n pi minus 1. This will be the an value. Okay.
Yes, sir.
So if we put n value is 1, then cos
Pi equal to
pi
minus.
equals to minus 1. Okay, so minus 1. If n value is 2, then plus 1. So plus 1 minus 1 cancel 0. That's why only odd numbers,
number.
odd numbers are will be found or are available. No even harmonics available in AN. Okay, so that
Yes.
we can write the series in that way, that a by 2 is the DC value minus, it will be minus 4, right? That's why minus 4a divided by pi square summation of 135, because only odd numbers are
Odd number.
available. That's why 135 to infinity. And n square is here, and cos n omega t will come automatically with the equation. So the series is formed. And from that series, you can find out the frequency diagram, frequency spectrum. Okay, I'm done up to this. So today I have given you a new technique to solve the Fourier series. If you have any question, you can ask me. Anyone has any question?
No, sir. I understand.
Okay, so understand. Thank you. I hope everybody understand. If anyone does not understand,